This is lesson 6-5, point slope form and writing linear equations. Point slope form is essentially y minus y1 equals m times x minus x1. This form of an equation is an equation of a non-vertical line that passes through the point x1, y1 and has a slope of m. This is the setup for getting an equation into slope-intercept form. The x1 and y1 is essentially your point. So if you can graph using slope-intercept form. All you have to do is understand how this works. So if I have the equation y minus 5 equals negative 2/3 parentheses x minus 2, and I want to graph using this, all we simply need to do is understand a couple of things. This right here is my slope. Okay. Let's see here. This right here is my y-coordinate. And last but not least, this right here is my x-coordinate. Which means this. I have a point and I know the slope, so I can use that point and I can use that slope to write an equation, or to graph my equation. Okay, so the first thing I'll do, x and y. Remember, that's negative 5 is the y-coordinate of my graph, of my point, excuse me, and 2 is the x-coordinate of my point. So my point is actually 2, 5, because the equation, if you remember back up here, the equation says y minus y1. So that if it's a plus, it's going to be the opposite. So if it said y plus 5, my y-coordinate would be negative 5. And if it said x plus 2, my x-coordinate would be negative 2. But since it's a minus and a minus, you read the coordinates just as you see them. Y equals 5 and x equals 2. So there's my point. And my slope, we already talked about that, the slope is negative 2/3. So I can find the point 2, 5. 1, 2, 1, 2, 3, 4, 5. There's my point. That's the point 2, 5. And now I can use the slope, which is negative 2/3, to find another point and graph my equation. Slope is negative 2 over 3, so down 2, right 3. So here's my second point. I can draw my line using a straight edge. We talked about this. And I can label it. Labeling this is a bit more hectic because you have to label it in point slope form. Y minus 5 equals negative 2/3 parentheses x minus 2. If you don't like graphing via point slope form, you can always simplify the equation, get it into y equals form, and graph it using slope-intercept. Let's look at problem 2 here. Y minus 2 equals 1/3 x minus 1. So my point, the x-coordinate of my point is 1. The y-coordinate of my point is 2. There's the x-coordinate of my point. There's the y-coordinate of my point. And my slope is 1/3. So I can very easily plot this point, use the slope, and graph my equation. My point is 1, 2, so over 1, up 2. There's my point, 1, 2. My slope is 1/3, so up 1, right 3. Up 1, right 3. There's my graph. And I can label it. Y minus 2 equals 1/3 parentheses x minus 1. It's another form of graphing. Not my favorite. I rarely use it because I really don't like point slope form. I don't like to leave things in point slope form. However, you have to use point slope form in order to get things into slope-intercept form. To write the equation of a line that has a given slope and a point, we just simply plug into the formula and solve the equation. So we're going to write the equation of a line with a given point and slope. So I have a slope of 7 and a point that's 3, 4. I'm going to write my equation. If you remember, the equation is written as y minus y1 equals m times x minus x1. So this point, this is x1 and this is y1 because x always comes before y when given a coordinate point. Stay in alphabetical order and you won't have a problem with that. So I'm just going to plug in what I know. y minus y1 is 4. So y minus y1 being 4, equals m, my slope is 7, parentheses, x minus x1 is 3. So all I did was plug in my coordinates for the point and my slope. We kind of call this a plug-and-chug problem. You plug in the numbers, now you're going to chug through it to solve it for y. So this would be in point-slope form, but we want to give the line in slope-intercept form. You always want to write your equations in slope-intercept form. This would be what we call point-slope form. And it is rarely the form that a mathematician wants you to leave anything in. They normally want you to write it in slope-intercept form. To write it in slope-intercept form, we're just going to solve this equation. So we're going to have y minus 4 equals, distribute the 7, so 7x minus 21. Add the 4 to both sides. And you're going to have y equals 7x minus 17. So this is what we call slope-intercept form. If in doubt, I always want your equations written in slope-intercept form. If you're not sure, leave them in slope-intercept form, because that's the most common form, and no matter what points you use, it will always be the same. Let's look at what happens when we have a fractional slope. This one was fairly straightforward because we had a whole number for a slope. Here, same thing. We're going to plug in our numbers. Remember, this is x1, this is y1. So you're going to have y minus 4 equals, my slope is negative 2/3, parentheses, x minus 1. That would be point-slope form. Now I want to get it into slope-intercept form, so y minus 4 stays. Now I'm going to distribute this negative 2/3 all the way through this, so I'm going to get negative 2/3 x. Now be careful, a negative 2/3 times a negative 1 is a positive 2/3. Watch your signs. Now I will add 4. This one is fairly simple because I don't need to get a common denominator because I'm just adding two positive numbers. So this would be negative 2/3 x plus 4 2/3. Or you could leave it as the improper fraction 14/3. Either one is acceptable. Slope-intercept form. Okay. You can also write an equation using point-slope form if you're given 2 points as well, with no slope. Simply find the slope first, which we already did in 6-1, and then use one of the 2 points. And it doesn't matter which set of points you use, as long as you use the x value and the y value from the same point. So this first problem here, we need to write the equation given points 5, 7, and 2, 6. First thing I'm going to do is I'm going to find my slope. And I've always told you I like to line up my numbers so that x's are above x's and y's are above y's, because the slope is the change in y, so in this case 7 minus 6 over the change in x, 5 minus 2. So 7 minus 6 is 1, 5 minus 2 is 3, so my slope is 1/3. Now I can use either point. I can use the point 5, 7 or 2, 6. It doesn't matter. I just can't use part of it. I can't use the x value from 5, 7 and the y value from 2, 6. I have to use all of the values from the same point. So I'm going to choose the first point just because it's the first point and it's easy, so I'm going to use the point 5, 7. So if I use that point into my equation, y minus y1 equals m times x minus x1. If you write this equation out a bunch of times, you will have it memorized. So my x value is 5, my y value is 7, so y minus 7 equals 1/3 parentheses x minus 5. Distribute y minus 7 equals 1/3 x minus 5/3 because you multiply straight across the top, straight across the bottom. Now I need to add the 7. Now I have to get a common denominator. Okay, because this is 7 over 1, which would be 21 over 3, right? That's why I like to write it this way, because it's very simple to simplify it right afterwards. So I'm going to get y equals 1/3 x. Negative 5 plus 21 is positive 16, plus 16/3. And you can leave it as 16/3. You do not need to make it 5 1/3. You can if you want to, you just don't have to. I tend to leave it in an improper fraction because when people make more mistakes trying to change it to a mixed number, than anything else. There we found the equation of the line in slope-intercept form given 2 points. Let's look at the second one. These are all negative. Don't let the negatives fool you. They're not difficult. You just have to remember to pay attention to your signs. So same equation. First thing I'm going to do, line them up so I can find the slope. Slope here, change in y, -5 minus a -6 over -1 minus a -7. So essentially it's -5 plus 6 because it's keep, change, change, keep, change, change. So we have -5 plus 6 is 1. -1 plus 7 is 6. So my slope is 1/6. So I have found my slope. Now I can use either point. I think I'll use the first point because 1s are easier to deal with than 7s and 6s. So if I plug it into the equation of y minus y1 equals m times x minus x1, y minus a -5 is equal to m(1/6) parentheses x minus a -1. Or it might be easier, y plus 5 equals 1/6 parentheses x plus 1. Because the minuses can get very, very cumbersome. Distribute, so we have y plus 5 equals 1/6 x plus 1/6. Now we're going to subtract 5 from both sides. These will cancel. 6x. Remember, we need a common denominator, so this is going to be 6. And this is going to be -30. -30 plus 1 is -29. So we have the equation of y equals 1/6 x minus 29/6. So that's writing an equation if given 2 points. So you can write an equation in slope-intercept form if you're given a point and a slope. You can write an equation in slope-intercept form if you're given 2 points, because you can use those 2 points to find the slope. The next thing we're going to do is if we're given a graph, we can use the point-slope form of the equation to find the equation of a line in slope-intercept form. And you might say, well, why can't I just use the slope of the y-intercept? Well, you could on this first graph, but if you look at the second graph, you'll notice that the y-intercept is not at a nice whole number. It is at an ugly fraction. You can try to guess at that fraction, but that would not be a good idea. If we look at this first problem here, this is the point 1,4. I can look at this and use my slope, because if I look at this, I can see up 1 over 1, 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 which means my slope is 1. So essentially, they did exactly what we did here. They did the y minus y1 equals m times x minus x1. So my slope was 1. So they did, the point was 1,4, so y minus 4 equals 1 parentheses x minus 1. Distribute through, y minus 4 equals x minus 1. Add 4. So y equals x plus 3. Simple, easy, straightforward. And we technically could have gotten that off the graph, because if I erase all this stuff, if you look at my graph right here, where's my y-intercept? It's right there at 3. So I could have read that off the graph, put it in y equals mx plus b, because there's y, the number in front of x is m, and this is my y-intercept of b. However, when I look at this second graph, that doesn't work so well. Because I look at the second graph and I'm like, ew, I do not know exactly what fraction that happens to be between 3 and 4. Here's my y-intercept right here. And I'm not exactly sure what point that is. I could make a guess, but most likely it's going to be wrong. And if I have a test question that hinges on this, I don't want to be wrong. So the first thing I'm going to do is I'm going to figure out the slope. I could either write the coordinates of the point to get the slope, or I could read the slope off the graph itself. It doesn't matter which. I'm going to see if I can read the slope off the graph itself. If I can go from this point to this point here, I should be able to read the slope. It's going up and to the right, which means it's a positive slope. This is 2 here. This is 3 there. So my slope is 2/3. The coordinates of the points. This is -2, +2. This point here is +1, +4. So those are my 2 points. It doesn't matter which point I choose to use for my equation. I'm going to use -2, 2, even though 1/4 could probably be easier, but I'm going to use this point just to prove that it doesn't matter which point you use. So if I do y minus y1, I'm using the point -2, 2. So y minus 2 equals my slope, 2/3, parentheses x, minus a -2, which means plus 2. There's my equation in point slope form. Now I need to get it into slope-intercept form. If I distribute here, I get y minus 2 equals 2/3 x plus 4/3. Now I'm going to add 2. These will cancel out, leaving me y equals 2/3 x. We get this in thirds, so that would be 6/3. 4 and 6 is 10 plus 10/3, or 3 1/3. Looking at my graph, does it look like it could have crossed the y-axis at about 3 1/3? Yeah, that looks reasonable. But would I have guessed that from the graph? Maybe, maybe not. So showing the equation means I really do know what I'm doing. Last thing. Since linear equations can be modeled in tables, it's important to be able to determine whether or not two sets of data have a linear relationship. In other words, will they make a straight line? Two sets of data will have a linear relationship or make a straight line if the rate of change between two consecutive pairs of data is the same. And remember, rate of change is a slope. So, it says, in the following tables, is the relationship shown linear? If so, model the data with an equation written in slope-intercept form. So the first thing I have to do if I'm given a table is I need to see and find out what the rate of change is. In other words, I need to look at the slopes. Okay? So if I look at the slopes between these 2 points, change in y, 6 minus 4 over change in x, 3 minus 2. Kind of nice, I already lined up for you. 6 minus 4 is 2, 3 minus 2 is 1, so my slope is 2. Then I'm going to go with these 2 points, which would be 4 minus a minus 2, which is 4 plus 2, over 2 minus a minus 1, which is 2 plus 1. 4 minus 2 is 6, 2 plus 1 is 3, that reduces to 2. So far, so good. And the last coordinates of these two, I'm going to have -2 plus 6, because minus a minus 6, and -1 plus 3, minus a minus 3. -2 plus 6 is 4. -1 plus 3 is 2. 4 over 2 is 2. So yes, this definitely models a linear relationship, doesn't it? Alright, so it says in the following tables is a relationship shown linear. So yes, this one happens to be linear. Okay? And then it says if it is linear, model it in a slope-intercept form. Well, we have the slope, now we just need to get the intercept, so we need to put it into y minus y1 equals m times x minus x1. So this is where I'm going to put the rest of my answer. So if I do y minus y1 equals m times x minus x1. So I'm going to pick any one of these points. It really doesn't matter. I'm going to highlight which point I choose because that way we won't get off track. I'm going to just choose that point because it looks nice. So I have y minus 4 equals 2 parentheses x minus 2. If I was to continue on, y minus 4 distribute equals 2x minus 4. Add 4. Add 4. Y equals 2x. There's my equation. That's slope-intercept form. Y equals 2x, or y equals 2x plus 0. So there's the equation. Yes, it forms a linear relationship, and the equation is y equals 2x. Let's look at the second problem over here. Let's see if the second table forms a linear relationship. Again, look at your pairs of numbers. I'm going to look at the change in y over the change in x. -2 minus a -1 over -2 minus a -1. So basically -2 plus 1, which is -1, over -1, which is just 1. Simply 1. Let's look at the second set of points. So these points right here. I have -1 minus 0 over -1 minus 1. -1 minus 0 is -1. -1 minus 1 is -2, so this becomes 1/2. These are not the same. Since they are not the same, it does not show a linear relationship. There is no relationship, so it's not linear. Simply done. If there is no constant rate of change, it is not linear, and therefore you can't model it in a linear equation. All right. We've done an awful lot in this lesson, so let's just do a real quick recap here. I, myself, prefer equations to be written in slope-intercept form. By doing so, there's only one answer. Okay? Whereas if you write the answer in point-slope form, depending on which point you use, you may have various answers. Let's go back and see. If I would have used a different point here, my point-slope form would have been different, but my slope-intercept form, no matter what, would have been the same, which is why I prefer slope-intercept form for an equation. Linear equations can be written in several forms, each having a benefit or a drawback. Okay, the slope-intercept form is y equals mx plus b, where m is your slope, and b is your y-intercept. Example, y equals negative 2/3 x plus 5/3. Standard form of the same equation is ax plus by equals c, where a and b can both not be 0 at the same time. And the standard form of that particular equation is 2x plus 3y equals 5. Point slope form, y minus y1 equals m times x minus x1. x1, y1 lies on the graph, and m is your slope. So we could use y minus 1 equals negative 2/3 parentheses x minus 1. All three of those equations are the same line, just written in different forms. As you can clearly see, this form here does not look anything like this form here. Hence why I kind of like it to be written in slope-intercept form. The slope-intercept form I can transfer to standard form, and we'll do that really quickly here. Y equals negative 2/3 x plus 5/3. Okay, first thing I would have to do is move this negative 2/3 x over here. So I would have positive 2/3 x plus y equals 5/3. Last thing to do is I have to get rid of the common denominator, which is to multiply everything by 3. Okay, so I'm going to multiply everything by 3. This 3 cancels, and I'm left with 2x plus 3y. These 3's cancels equals 5. Notice, same as that form right there. So 3 different forms. They each have their benefits and drawbacks. They each have times when you need to use them. So you need to memorize all 3 types of these forms. It will be to your benefit if you memorize them.